Welcome back to Next Now, your inside track on the infrastructure shaping the AI era. I'm your host, Nexus, and today we're exploring how universities are supercharging AI research with NVIDIA H200 technology, igniting a global race for innovation. Academic research is undergoing a powerful shift, driven by the growing demand for unprecedented computing performance. Around the world, universities are no longer standing on the sidelines. They're actively deploying NVIDIA's cutting-edge H200 Tensor Core GPUs to build next-generation AI factories, SuperPODs, and sovereign cloud platforms capable of tackling the most demanding AI workloads. But this evolution isn't just about faster processing. It's about enabling foundational model training, supporting federated learning across institutions, and delivering real-time inference at scale. These capabilities have moved from experimental to essential, powering breakthroughs in science, medicine, climate research, and even transforming how education is delivered. And this is only the beginning. While the H200 currently represents the pinnacle of GPU performance in academia, NVIDIA's roadmap is already looking ahead to the Blackwell-powered B200. Institutions investing in H200 infrastructure today aren't just accelerating current research. They're laying the foundation to adopt future generation platforms with minimal friction. This pivotal shift isn't a future promise. It's a present reality. Forward-thinking institutions worldwide are already integrating the H200 into their research ecosystems. In the United States, Oregon State University stands out, strategically weaving the NVIDIA DGX-H200 into its computational backbone. Similarly, Georgia Tech's AI makerspace is buzzing with activity, powered by significant clusters of H200-HGX servers, creating fertile ground for groundbreaking AI development. In Asia, National Yangming Chiao-Tung University in Taiwan has launched an AI high-performance computing platform including NVIDIA DGX H200 servers, a first for a Taiwanese university. The University of Tokyo in Japan is leveraging NVIDIA Grace Hopper superchips for energy-efficient seismic research. Seoul National University in South Korea, through collaboration with Exhibits, is gaining access to a network integrated with 4,000 NVIDIA H200 GPUs. Looking to Europe, Eindhoven University of Technology in the Netherlands is set to be an early adopter of NVIDIA DGX B200 systems, demonstrating a commitment to next-generation AI infrastructure. Furthermore, national initiatives like Taiwan's NCHC are deploying large-scale NVIDIA HGX-H200 systems, making significant GPU resources accessible to academic researchers across the nation. Closer to home, Trobe University has emerged as Australia's innovation leader, becoming the first Australian institution to deploy NVIDIA DGX H200 systems. This isn't merely an upgrade. It's the very foundation of their new world-first Australian Centre for Artificial Intelligence in Medical Innovation, or ACAMI. ACAMI is set to become the globe's first university centre dedicated specifically to leveraging AI for developing immunotherapies, cancer vaccines, advanced medtech, and transformative healthcare solutions. These investments are not just powering research, they're driving new patents, industry partnerships, and national competitiveness. From climate simulation to cancer vaccine pipelines, these universities are translating AI power into societal good and economic return. As Vice-Chancellor Professor Theo Farrell aptly puts it, this move is absolutely central to La Trobe's vision of leadership in AI education and research, with their responsible AI adoption strategy guiding every facet of university operations. La Trobe joins a growing international cohort of universities establishing AI-focused research precincts, from Princeton's Open Generative AI initiative to Denmark's national AI supercomputer Gaffion, each turning infrastructure into innovation pipelines. These institutions are setting the pace. The question now is, will others follow or fall behind? The impact of next-generation AI infrastructure isn't limited to computer science. When universities gain access to high-performance systems like those powered by the H200, The effects ripple across every faculty, changing how research is done, how students learn, and how knowledge is applied in the real world. Climate scientists can run ultra-high resolution models to better predict environmental shifts and uncover patterns once hidden in complexity. Medical researchers can explore genomics and personalised healthcare with speed and scale, accelerating the path from data to discovery. Engineers can simulate real-world systems in astonishing detail, optimising designs, materials, and performance long before anything is built. Legal scholars and ethicists can engage directly with the societal implications of AI, shaping the governance frameworks the world urgently needs. Linguists and cultural experts can preserve and revitalise Indigenous languages using AI-powered synthesis, analysis, and reconstruction tools. Educators can build adaptive learning systems that personalise teaching, reshape pedagogy, and meet students where they are. Economists and business researchers can model dynamic systems in real time, gaining sharper insight into markets, trade, and policy impact. Public policy experts can develop civic AI tools that make government more responsive, data-informed, and community-focused. This isn't just about faster computing, it's about unlocking new possibilities in research, education, and how universities shape society. When universities invest in infrastructure built for AI at scale, they unlock a new era of interdisciplinary innovation. Trobe University's pioneering deployment isn't just an institutional milestone, it's a signal of Australia's growing presence on the global AI stage. It marks a critical step toward building sovereign AI capability at a time when secure, high-performance digital infrastructure has become a national priority. Australia's private sector is also stepping up. Leaders like Sharon AI and Reset Data are rapidly building sovereign H200 powered superclusters, designed to meet the country's unique trust, performance, and data sovereignty requirements. These advanced platforms are now within reach for universities, available via cloud or direct partnership, forming the backbone of a dynamic, interconnected national research ecosystem. For universities, this isn't just about compute. It's about unlocking greater research impact, forging new cross-sector partnerships, and increasing eligibility for major government-backed AI grants. Institutions that move early won't just accelerate their own research, they'll help shape Australia's position as a global AI leader. At the heart of this transformation is NEXTDC. As an ASX 100 listed technology leader and Asia Pacific's leading data centre as a service provider, NEXTDC is delivering the digital infrastructure that underpins Australia's AI future. These aren't traditional data centres, they're purpose-built, NVIDIA DGX-Certified Tier 4s environments engineered to support high-density GPU clusters and advanced liquid cooling systems required for next-generation AI workloads. One example of this is Sharon AI's H200 supercluster, hosted at NEXTDC's Melbourne facility. It operates within a secure, high-availability, high-performance environment designed specifically for mission-critical AI deployments. Beyond raw infrastructure, NEXTDC's Axon Interconnect Fabric delivers seamless, low-latency connectivity across institutions, research groups, and cloud platforms, making it possible to run large-scale, distributed AI workloads with efficiency and precision. The global race to lead in AI is accelerating fast. For university leaders, chancellors, vice-chancellors, CDOs, CTOs, and deans, the message is clear. Delaying AI infrastructure investment means falling behind in ways that may soon be irreversible. The risks extend well beyond IT. They touch research impact, reputation, and competitiveness. Major research grants, especially those for AI-intensive or sovereign tech programs, increasingly require access to advanced, high-throughput computing environments. The ability to publish high-impact, data-driven research is directly tied to infrastructure. Without it, global standing erodes. Today's students expect hands-on experience with the tools shaping tomorrow's industries. Institutions lacking that capability risk losing top-tier candidates to better-equipped peers. Leading AI academics won't join institutions that can't support the scale, complexity, and speed their research requires. Without modern compute environments, universities limit their ability to launch AI-powered startups, license breakthrough IP, or drive commercial outcomes from research. Global peers are already aggressively deploying H100 and H200 infrastructure, actively building innovation hubs and sovereign AI programs. The gap is widening and it won't wait. This is your moment to lead, to set the national precedent, to define your institution's legacy in AI-powered discovery. The universities that act now won't just keep pace, they'll define the future. For chancellors and vice-chancellors, this means positioning your university at the forefront of Australia's AI future. Attract major research funding, build world-class partnerships, and elevate your institution's global standing in the innovation economy. For deans and faculty leaders, enable your schools to launch interdisciplinary, AI-powered programs that shape new fields of study without being limited by infrastructure or outdated systems. For research professors and AI academics, train large-scale models, run complex simulations, and meet critical funding timelines with speed and scale. Focus on research, not on waiting for compute. For CDOs and CTOs, lay the digital foundation for the next decade of discovery. Build secure, energy-efficient, and AI-ready infrastructure that adapts as your research ambitions grow. NVIDIA chips are not just hardware, they're a strategic enabler of research leadership, interdisciplinary innovation, and global competitiveness. They power more than computation. They unlock possibilities, helping universities accelerate discovery, attract top talent, and shape the future across science, medicine, climate, education, and society itself. NEXTDC is more than a data center provider. We are your strategic partner in building sovereign, scalable, and sustainable AI infrastructure designed to accelerate every stage of academic discovery. With planned expansions across Asia, NEXTDC is evolving into a regional AI infrastructure leader, offering universities millisecond access to key research and commercial hubs across the Asia-Pacific, enabling seamless international collaboration and next-gen model deployment. Why partner with NEXTDC? Enterprise-grade AI environments, purpose-built to support high-density NVIDIA H100/H200 GPU workloads with certified DGX-ready design, liquid cooling, and extreme power density. Sustainability leadership, energy-efficient operations, and advanced cooling architectures that align with your university's ESG and cost efficiency goals. Sovereign and secure research capability. Ensure your AI data and intellectual property remain protected within Australia's jurisdiction, backed by compliance with the highest national standards. Global AI routing and interconnection. The facilities are located near every major international subsea cable, landing station, and across every Australian capital city, enabling ultra-low latency routes for federated learning, edge AI, and multi-region training. Unmatched ecosystem access. Gain the largest selection of cloud, GPU as a service, and neocloud on-ramps in Australia, providing immediate access to hybrid and burst AI workloads without infrastructure delays. Australia's leading universities are already building the infrastructure to power tomorrow's AI breakthroughs. Partner with NEXTDC to unlock scalable, AI-ready environments, purpose-built to support advanced research, accelerate innovation, and drive real-world impact. Our dedicated education team is ready to support your institution in shaping the next generation of discovery, collaboration, and leadership in an AI-powered world. Thanks for tuning in to Next Now. If you're building or scaling AI infrastructure and want to know what ready for AI actually looks like in practice, stay with us. More insight coming soon.